to me. I'm just hoping I don't repeat history. Boy, I'm trying to meet your mama on a Sunday. The nigga I love on a Monday. Never need no one else, babe. Cause I'll be switching in positions for you. Cooking in the kitchen and I'm in the bedroom. I'ma need a lift, they say I'm jumping through hoops. For my love, infinite, nothing I wouldn't do, but I won't do. Switching for you, perfect, you're too good to be true. But I get tired of running. Now I'm running with you. So boy, I'm tryna meet your mama on a Sunday. The nigga I love on a Monday. Never need no one else, babe. Cause I'll be switching in positions for you. In the kitchen and I'm in the bedroom. I'ma need a lift, they say I'm jumping through hoops. For my love, infinite, nothing I wouldn't do, but I won't do. Switching for you. Cooking in the kitchen and I'm in the bedroom. I'ma need a lift, they say I'm jumping through hoops. For my love, infinite, nothing I wouldn't do, but I won't do. Switching for you. There's something that I usually don't do, but for you I kinda want to. Cause you're down for me and I'm down too. Yeah, I'm down to. Switching in positions for you. There's something that I usually don't do, so for you I kinda want to. Cause you're down for me and I'm down too. Switching in positions for you. Kitchen and I'm in the bedroom. I'ma need a lift, they say I'm jumping through hoops. For my love, infinite, nothing I wouldn't do, but I won't do. Switching for you. Cooking in the kitchen and I'm in the bedroom. I'ma need a lift, they say I'm jumping through hoops. For my love, infinite, nothing I wouldn't do, but I won't do. Switching for you. Yeah.
Hey, yo, hey, hey, oh, finding myself, showing myself, finding a way to stay out of the way, holding me back, it's supposed to come right back, guarding myself while I'm all on display. I know you know all about it. I know deep down you feel the same. I know you know I feel. I know you know how I feel. How do I feel? How do I feel? How do you say to my face, time heals, then go and leave me again? Unreal, I see us fading away. I'm still holding my breath for the day that you will see that the effort I make is too real. How can you say that you know how I feel? Hey, how can you say you know what I'm feeling, know what I'm feeling? You don't feel nothing, nothing is healing. Time is just killing. How can you say you know what I'm feeling, know what I'm feeling? You don't feel nothing. Time isn't healing. Time is revealing. How are you feeling? You don't feel nothing.
Please rise for the singing of the national anthem. Oh, say, can you see by the dawn's early light what so proudly we hailed at the twilight's last gleaming, whose broad stripes and bright stars through the perilous fight o'er the ramparts we watched were so gallantly streaming, and the rocket's red glare, the bombs bursting in air, gave through the night that our flag was still there. Oh, say does that star-spangled banner yet wave o'er the land of the free and the home of the brave?
Good afternoon. Let's give another round of applause for our soloist, Caitlin King. Caitlin is a member of the class of 2024 and is graduating from the Engineering Honors Program, summa cum laude, with Bachelor's of Science degrees in Biomedical Engineering and Robotics. Thank you, Caitlin. I'm Steve Sessio, the Interim Dean of Engineering, and it's my tremendous honor to welcome you all to Chrysler Center for the graduation ceremony for the graduate class of 2024E. Congratulations. This is a momentous occasion. It's a time to look back and recognize your many accomplishments, as well as the many challenges you've overcome to get where you are today. Whether you started your academic experience in the midst of a once-in-a-century pandemic or endured through personal challenges and global tragedies, every graduate in this room has experienced a unique journey that has shaped you into the engineer you are today. You are a special group, and you made it. I encourage you to reflect on the challenges you faced and the lessons you learned because of them as you proceed forth as a graduate engineer. You always think about instructors who had a lot of impact on your life, and there's one that had an impact on mine. One of my earliest instructors was this fellow called Gandalf the Grey. Some of you may have heard of him. I think he was recently promoted to Gandalf the White, that's what I understand. But Gandalf said, and I quote, "All we have to decide is what to do with the time that is given to us." In other words, you can't choose the times you were born into or live in, but you can choose what to do with the time you have. Now, thankfully, you won't face the same dangers that Frodo encountered on his journey to Mordor, but this quote still speaks to the opportunity we all have to step up to the challenges of our time. As I look out into this crowd, I don't see hobbits, but I do see fellowship. I see future leaders, problem solvers, researchers, educators, and mentors in your communities. I see your determination and grit, your camaraderie and your passion, and desire to overcome social inequities and make the world a better place. I hope that you forever cherish the memories you made here at Michigan Engineering. Whether that was making a new discovery in a lab, successfully troubleshooting an issue in the Wilson Center, finding your community, and bonding with peers, or celebrating, I don't know, a national championship football team. We'll wait for basketball. You can always count on the lessons you have learned as a Michigan engineer to carry you forward, whether that was through making treks on your own between North and Central Campus, to collaborate with people from different disciplines and areas of expertise, learning from some of the strongest academics and research minds in the nation, or seeking out and understanding problems from multiple perspectives so that you can make a real positive difference in the world, putting people first. You now join one of the most accomplished groups of engineers, the Michigan Engineering Alumni. Take what you've learned and apply it in your next journey. I look forward to learning about your continued success and the positive impact you will impart on the world. Once again, congratulations, and forever, Go Blue, class of 2024. The administrators of the college, including the executive committee, associate deans, department chairs, and program directors, serve in various capacities to help the College of Engineering pursue its vision, mission, and values and people-first framework. All of our outstanding faculty members are also vital to upholding the college's excellent reputation and making possible your impactful student experience. Would the college's faculty and administrative leadership please stand as you are able? Let us also recognize two special guests and friends of the college from the University Administration. Mike Solomon, Professor, Dean, and Vice Provost for Academic Affairs, Graduate Studies, Rackham Graduate School, and Valeria Bertacco, Mary Lou Dorff Collegiate Professor of Computer Science and Engineering, Vice Provost for Engaged Learning, Executive Vice President for Academic Affairs, and Professor of Electrical Engineering and Computer Science. Thank you for joining us. Now, a tradition of the college's commencement ceremony is to hear from a student. This year's student speaker is Oluwame Dosunmu Ogumbe, affectionately known as Wami. Wami is graduating today with a PhD in robotics. She holds dual master's degrees in robotics and mechanical engineering from the University of Michigan and a bachelor's degree in mechanical engineering from the University of Illinois at Urbana-Champaign. During her time at Michigan, Wami has held leadership roles in student organizations, mentored 8 undergraduates and master's students, and inspired countless others through her outreach activities. Her future plans are to become a professor and to equip future engineers with a global perspective. Wami, please come forward.
What's up, class of 2024? Let me be the 137th person to congratulate you on this truly extraordinary achievement. My name is Oluwame Dosunmu Ogumbe, or just Wami. And if you do not know me right now, that is okay. But I want you to remember me as the University of Michigan's first Black woman to get a PhD in robotics. We did it, class of 2024. We can officially call ourselves Michigan Engineers. As we celebrate this momentous occasion, I want us to reflect on why we chose to become engineers. For some, it may be because you like working with your hands. For others, you like tearing things apart and hopefully putting them back together again. I am here because I really wanted to wear this funny hat. That is no joke. At my high school graduation, I saw one of my teachers in fancier regalia than the rest. In classic neurodivergent fashion, I hyper-fixated on wanting to wear the same funny hat that she was wearing. When someone told me that I needed to get a PhD to wear it, I said, cool, I guess I'm going to get a PhD then. What are the field options? They responded, well, you are the child of Nigerian immigrants, so your options are doctor, lawyer, or engineer. So I thought about it. Well, I can't be doctor because I hate blood. Lawyer is out because I would pass out if I ever had to talk in front of a large crowd of people. So I guess that just leaves engineer. Regardless of what spurred you down the path of becoming an engineer, you have made it to this milestone. We are engineers. More significantly, we are Michigan engineers. A Michigan engineer is one who does not just provide scientific and technological leadership, but also is one who is intellectually curious, socially conscious, creates collaborative solutions to societal problems, and promotes an inclusive and innovative community of service for the common good. We each have a solemn duty to make positive contributions to the world. While my reasons for becoming an engineer were initially frivolous, they did eventually morph into something more meaningful. I want to have a positive impact on the world. I do not stand here on my own 2 feet alone. None of us got here by our individual merit alone, whether it be teacher, family, friends, mentors, or role models. We each have one or multiple people to whom we are grateful for making this moment possible. I almost did not make it to the stage. In January of 2020, I had to leave my previous PhD program. I had worked so hard, attaining honors, awards, and academic merit, and yet I still failed. Thankfully, nothing else happened later that year in 2020 to make things exponentially worse. But clearly, something positive eventually did happen. After all, I am standing on this stage. It was through the support of my faculty mentors who saw my situation and gave me a second chance. I share this story to emphasize the critical importance for us to be socially conscious and promoting diversity, equity, and inclusion in our solutions. Remember the people in your lives who loved and supported you through your achievements. Embody their positive impact in your life to build a future that will elevate all people, for those already here and those yet to come. This is the core of the Michigan engineer, to put people first. The people whom you positively affect will turn around to positively affect others. And who knows, maybe you can help a little girl achieve her dream of wearing a funny hat. Thank you. Congratulations, class of 2024, and forever, go blue.
Thank you very much, Wami. Now it's my honor to introduce our keynote speaker, Kunle Olokotun. He is the Cadence Design Professor of Electrical Engineering and Computer Science at Stanford University. Known as the father of the multi-core processor, Dr. Olokotun developed ideas for multi-core processor design in the 1990s that are now the mainstay for all modern computing systems. It is not an exaggeration to say that everyone in this room has been impacted by his creativity. And more recently, he developed new ways of designing specialized computer systems to meet the huge computational demands of AI and machine learning applications. He is passionate about sustainability, responsibility, and community relations, and he is the co-founder of multiple companies that translate his research innovations into commercial products. He's a member of the National Academy of Engineering and the American Academy of Arts and Sciences, a fellow of the Association for Computing Machinery, and in the Institute of Electrical and Electronic Engineers. And, what do you know? He received his PhD in computer engineering from the University of Michigan. Please help me welcome back to Ann Arbor, Dr. Ola Kodtun.
Thank you very much for the welcome. Thank you very much, Steve. So welcome graduates, faculty, families, and honored guests. Today we gather to celebrate the achievements and the potential of the graduates of the University of Michigan College of Engineering. A frequently quoted adage about the future is the best way to predict the future is to create it. This quote resonates deeply with me because it challenges not merely to be passive observers or anticipators of what's to come. Instead, it calls us to take an active role in steering the course of the future. The quote insists that we bear a responsibility for the future, an idea of tremendous importance for engineers like yourselves who stand on the front lines of a world increasingly shaped by technology. Throughout my academic career, I've attended numerous commencement speeches. While most have faded from my memory, there's one that remains vividly clear: Steve Jobs' 2005 address at Stanford. He shared 3 poignant stories from his life, each with a distinct message about how we should interact with the world and with our fate. Inspired by the structure of his speech, today I will share 3 personal stories centered around the theme of creating our future. The first story I want to share with you is about how our past prepares us for our future, a concept Steve Jobs described as connecting the dots. During my undergraduate years at Michigan, I discovered my passion for computer hardware design, otherwise known as computer architecture. This realization happened while working with Trevor Mudge in the robotics lab, housed back then on Central Campus in what you now know as East Hall. We knew it as East Engineering. As an undergraduate researcher, my task was pretty straightforward, yet it was groundbreaking for the time. Develop a vision system, recognition system to enable a robot to locate a simple object on a table and move that object from one place on the table to another. The technology of the era was primitive compared to what we have today, and after countless nights in the lab, finally I got the system to work. And the experience was eye-opening. I was astounded at how much faster the special purpose vision hardware was compared to the workstations that we had in use for similar applications. And the project was my first exposure to the performance impact of specialized computer hardware. It was fascinating, yet it also introduced me to the challenges of programming this hardware and how difficult it was to write correct and efficient software for these specialized computer machines. And so this early realization has become the cornerstone of my career, which is focused on bridging the gap between specialized computation and the ease of general-purpose programming with which you are so familiar. I first began to understand how fundamentally it was the interplay between hardware and software that I first became to understand doing work in the robotics lab in East Hall. It's crucial to solving this problem. So now when industry professionals and students come to me with their new ideas for computer hardware, my initial inquiry was always focused on the broader impacts. I asked them, what are the implications of your hardware design to software? This question stems from those formative experiences in the robotics lab, underscoring how our past shapes our future thinking. My second story centers on creativity and unconventional thinking, principles epitomized by Steve Jobs' mantra to think different. So when I arrived at Stanford in the early 90s, I was initially overwhelmed. The campus was bustling with famous professors and very bright graduate students, and I doubted my ability to make a meaningful contribution. But as I gained confidence, I learned that earning recognition within academia hinges on introducing groundbreaking viewpoints that challenge conventional thinking. I launched the Hydra Project, named after the multi-headed beast from Greek mythology. The aim was to design a microprocessor with multiple CPUs, a concept that was radical at the time, but it's commonplace now. The prevailing focus of the academic and industry community was on single-core processors, and the conventional wisdom was that multi-core processors were inefficient and impractical due to their destructive impact on software. Despite facing considerable resistance and challenges to publishing our findings, I and my research team persevered. I'm sure some of you have had experience of paper rejections during your time here at Michigan. Eventually, we succeeded in publishing the paper that addressed both the hardware and software aspects of multi-core processor design, and this has become a seminal paper in computer architecture and was instrumental in redirecting both the academic community and the industry to focus on multi-core technology. So at that time, I tried to convince the engineers at leading microprocessor companies to embrace multi-core technology. However, none of them showed interest. A colleague of mine at Stanford then offered a piece of advice that has changed the course of my career. He told me, if industry is interested and you believe it's a good idea, then have the courage of your convictions and pursue the idea yourself. So that's what we did. Inspired by this advice, I co-founded Afara Web Systems to develop computers for the booming internet servers that were used in data centers. At that time, they were running out of both space and power. We pitched to the venture capitalists that our multi-core based servers could really address these issues and solve these problems. And with VC funding, we assembled a world-class team of software and hardware engineers to pursue the idea. Our efforts culminated in the design of what was called the Niagara processor, which ultimately became the cornerstone of the Sun Microsystems servers, and these were later used at Oracle. Our radical idea for improving performance and energy efficiency paid off, literally generating billions of dollars of revenue. The entire journey began with a challenge to conventional wisdom and was sustained by a resilience to push through many obstacles. But more than that, it was a vivid illustration of what it means to create the future. By choosing to pursue the Hydra project and later founding Afara, we weren't just responding to current trends or demands, we were anticipating and shaping what could be. Our decision to develop multi-core technology at the time, when the industry was focused elsewhere, was a gamble, but it was driven by a vision of the future, a future where energy efficiency would become paramount. This vision required not just technical innovation, but also a new way of thinking about what was possible in computing technology. So as you embark on your careers, remember that creating the future often means being ahead of your time. It involves envisioning a world that doesn't yet exist and having the courage to make it real. The challenges are significant, and you may face skepticism and resistance, as we did. However, the opportunity to pioneer change and make a lasting impact is a true reward for thinking differently. Today, every microprocessor utilizes multi-core technology, and the design principles we championed are now standard. The smartphone in your pocket, the servers that power our internet, and countless other technologies benefit from the path that we help pave. As engineers and graduates, you too have the power to foresee and forge the future, and to innovate solutions for tomorrow's problems. The final story I want to share with you is about finding your passion. Steve Jobs said, "The only way to do great work is to love what you do. If you haven't found it yet, keep looking. Don't settle." This is good advice because it suggests that finding what you truly love is often a journey of discovery. Along the way, you will do the work that you will be proud of. When I graduated from Michigan, my sights were set firmly on going to industry. And I wanted to design real computers that people could use and make meaningful changes in their lives. But a chance meeting with Professor Michael Flynn from Stanford shifted my trajectory towards academia, a path I had not seriously considered before. In academia, I discovered a passion for mentoring young people, whether it's explaining fundamental engineering principles to undergraduates or leading PhD students in the process of discovery by pushing them to ask thought-provoking research questions. My aim has always been for students to develop their capacity for insight and creativity to help them reach their potential. Over the years, I've advised many PhD students. A couple of them are on the faculty of the University of Michigan. It has been immensely gratifying to watch these students develop into full-fledged researchers in their own right, and I'm constantly amazed by the results that they produce. Our collaborations have advanced the fields of computer science and reshaped the way computers are designed and programmed. Some of my students are eager to turn their academic breakthroughs into real-world solutions. I continue to advise them as they transition from academia to startups. For instance, a team of my PhD students recently developed technology to improve the performance of AI applications with the goal of making the benefits of AI cheaper and more accessible to more people. With my guidance, these students have founded Sambonova Systems, and through Sambonova, they've had the pleasure of seeing their doctoral research serve as a basis for AI systems that enhance scientific research, improve medical diagnostics, and allow enterprises to be more productive. In my career journey, I've discovered my passion for guiding the next generation of engineers who are now creating the future. And as you embark on your own careers, I encourage you to embrace experimentation and challenge technical norms to discover and pursue what truly ignites your passion. So remember, the best way to predict the future is to create it. It isn't just encouragement, it's a directive, an invitation to each of you to play an active role in shaping a world that aligns with our highest ideals and aspirations. You, the graduates of the University of Michigan College of Engineering, are exceptionally equipped to take on this mantle. You're entering a world full of possibilities, a world that awaits your ideas, your innovations, and your contributions. Whether it's advancing technology in any of the engineering disciplines, developing sustainable solutions, or creating more equitable technology, your work can and will make a difference. So let's create the future. Let's build it with intention, with imagination, and with an unwavering commitment to making our world a better place. Congratulations, class of 2024, on all that you have achieved and all that you are about to accomplish. Go Blue!
Thank you, Kunle, for inspiring us with your actions, your words, and your deeds. This event celebrates a major achievement by today's graduates. But graduates, you have received help along the way from parents, grandparents, spouses, siblings, and other family and friends. I now ask the special people who are with us today to stand as they are able so that you, the graduates, may thank them. Please stand. Thank you. Now at this time, I will call the names of each of the college's department or division chairs. Leaders briefly will greet their department students on stage. I now ask that these individuals to stand and remain standing as I call your names. Audience, please hold your applause until the entire group has been recognized. Carlos Sesnick, Aerospace Engineering. Marianne Misek, Biomedical Engineering. Sharon Glotzer, Chemical Engineering. Yafeng Yin, Civil and Environmental Engineering. Tulia Pulkkinen, Climate and Space Sciences and Engineering. Michael Wellman, Computer Science and Engineering. Dennis Sylvester, Electrical and Computer Engineering. Julie Simons-Ivy, Industrial and Operations Engineering. Mickey Banu, Integrative Systems and Design. Liz Holm, Material Science and Engineering. Ellen Aruda, Mechanical Engineering. David Dowling, Naval Architecture and Marine Engineering. Todd Allen, Nuclear Engineering and Radiological Sciences, and Dawn Tilbury, Robotics. Thank you. Now I'd ask that the first team of name announcers to please take your positions. Ushers will direct graduates to the stage in 2 lines. We've got our name readers, and we're getting set. Beginning from the front of the arena, each student marshal will lead by holding their department or program flag. Graduates, you will be greeted on stage by your department representatives and by Dean Solomon and/or me. It is a tradition as you cross the stage to move your mortarboard tassel from right side to left to reflect your transition. Then please return to your seat in the audience and remain seated until the conclusion of our program. In the spirit of Michigan Engineering Unity, we want all departments and students to be recognized by a full audience. And we would invite your family, friends, and supporters to cheer, briefly, as your name is called. After our last graduate is recognized, we will sing the victors. Now, would the candidates for the degrees offered by the Departments of Aerospace Engineering and Chemical Engineering please rise and approach the stage to begin the recognition of graduates.
Department of Aerospace Engineering, Rohan Chundratre. Dr. Joseph Breeden, Constrained Control and Online Safety Filtering for Autonomous Space Systems. Let's give them a chance to start.
Department of Chemical Engineering, Dr. Emma Brennan, leveraging National-Ofley particle indications to develop temperaments for acute inflammation.
Riley Richards.
Isabella Ferrante.
Aditya Pati Tripathi.
Dylan Marks.
Dr. Caleb Van Beck, the development of design tools for optimized next-generation propulsion systems.
Jacob Miller.
Anujay Singh.
Department of Material Science and Engineering, Jean Liang.
Bernardo Bahia Monteiro.
Yushen Liu.
Dr. Bilal Sharkey, ground vibration testing and finite element model updating of very flexible aircraft.
Jindong Huang.
Caitlin Martinez.
Xiaobo Tong.
Andrew Wong Su.
Yimo Ho.
Cole Helsel.
Dr. Yikao Huang, development of mental selenide and semiconductor nanocomputers through cotton exchange in room temperature.
Abhi Kandor.
Druya Krishnaswamy.
Hunter Sagerer.
Austin Lamb.
Carter Briggs.
Jason Landini.
Yiling Den.
Joshua Samuels.
Sunyan Hu.
Mariano Samuels.
Dr. Rowan Tu, additive manufacturing of high performance and piezoelectric polymers through precipitation printing.
Eli Rotman.
Yuton Chen.
Leah Fleming.
Tong Yan.
Yushen Dang.
Ingshi Shen.
Aaron Cook.
Kai-Sheng Li. Samuel Sugarman. Anis Ramon.
Dr. Qixing Zheng, investigating adhesion of degradation of polymer materials for industrial applications.
Janani Perry.
Yushuan Chen.
Vaishnavi Harikumar.
Su Yun Hong.
Shruti Vutukuri. Baris Osma Denji.
Oguz Santikaya.
Maxfield Satius.
Fatma Sandinkaya.
Samantha Romano. Adrian Jules Rocha.
Zinan Zhang.
Michael Tigner.
Maheshwari Kakare.
Ian Sheikh.
Vedant Gaikwad.
Rudwig Majumdar.
Antojerish Jayadimal.
Tyler Linfesti.
Dr. Ju Won Lim. Calorimetric system to explore radiative thermal transport and the thermodynamics of hydrogen reaction for energy utilization.
Weixiao Wang.
Makoto Kimura.
Lorenzo Largent.
Department of Naval Architecture and Marine Engineering. Logan Galindo.
Michael Fisher.
Sebastian Clark.
Morgan Sarah.
Franklin Fee.
Kira Paris.
Zachary Duval.
Sarah Hezi.
Cooper Clark.
Kavya Saravanan.
Brian Axelson.
Alexandra Strelo.
Min Kwan Win.
Tongji Lee.
Carson Denman.
Marcus Lowe.
Daniel Karuta.
Moon Bakaya Hazarika.
Joshua Beatty.
Aruma Kujwaha.
Dimitrios Dikos.
Noah Burns.
Daniel Coles.
Fan Wang Cheng.
Jin Yok Yu.
Siddhant Devaru.
Muhammad
Vignesh
Baudul
Iyer.
Shaluddin.
Achu Shankar.
Department of Civil and Environmental Engineering. Yu Yang Zhao,
Ruhani Avula,
Sin Yu Dang,
Srinjoy Dasgupta,
Tanapat Suduwana,
Vishwa Mohan Tiwari,
Tina Wang,
Epafras Ernesto Bomerves Sihombi,
Bohizdara Protokipova,
Rami Al-Hazmi,
Satromani Bun,
Osama Adel Badula,
Jose Marquez,
Rohan Chandra Madatil,
Brody Mehdi,
Tanushri Shinde,
Dr. Kay Lynn Jones, the influence of local hydrodynamics on fish movement in the fluvial infrastructure.
Ushwan Lin,
Dr. Ellen Thompson, enhancing predictions of the carbonate dissolution behavior using quantitative heterogeneity metrics from XCT data.
Shaushwat Patnaik,
Rosalia Otadui Ramirez,
Kian Molani,
Isis Hang,
Boomer Perry,
Si Yen Hao,
Climate and Space Sciences and Engineering, Andre Jones,
Muhammad Iqbal Witarama,
Madeline Purvis,
Chen Wei Wang,
Tabrin Porter,
Caleb Wegner,
Ethan Bruce,
Eric Dubert,
Rochelle Winterberger,
Daniel Galino,
William He,
Yuang Guo,
Peyton Paulus,
Hen Ring Yu,
Lawanya Awasti,
Jia Wan Ji,
Majabin Haq,
Tian Hao Zhu,
Samuel Tan,
Robert Marks,
Brian Cromwell,
Zheng Yi Tang,
Dr. Chongxing Fan, the importance of accurate physical parameterization for radiative transfer in global climate simulations and remote sensing, examples of cloud long-wave scattering and solar farm modeling.
Paige Yamani,
Anushri Manwatka,
Ethan Hiss,
Ram Yu, sorry, Basha Krapat Solfulu,
Matthew Cotton,
Luthien Liu,
Gina Kittleson,
Erica Mendes Valequez,
Scott Carlin,
Haley Bazino,
Alexander Vandaway,
John Oberlees,
Julian Malherbe,
Robotics, John Hutchinson,
Julia Scheischinger,
Dr. Alwumi Dosunu Ogumi. Ascending new heights, enhancing bipedal robotic locomotion through stair climbing.
Reese Lynch,
Dr. Joseph Kim, enhancing safety, efficacy, and resilience in advanced air mobility through geofencing, contingency management, and optimized network strategies.
Emma Johnson,
Jessica Carlson,
Anna Kiltz,
Arthur Lovekin,
Rachel Pastori,
Peter Stratton,
Maya Gallagher,
Robert Fry,
Yi Lian,
Anastasia Varna,
Achuth Dev,
Isha Bhatt,
Puravaja Patil,
Sukrufi Chidananda,
Alexander Zunt, Dr. Alexander Zunt, enhancing writing pool operations, algorithms, heuristics, and simulation-based approaches.
Shiram Puridaharshan,
Tianrun Chin,
Thi Pumelish Askokama,
Chi Yu Her,
Ali Abdullah,
Nicholas Sirait,
Ashish Kumar,
Department of Biomedical Engineering, Danielle Raza,
Madhva Rahwal,
Leon Jacob Wagner,
Uju,
Stephen Gong,
Ke Liu,
Junsu Kim,
Uju Tio,
Austin Cornish,
Pojun Chun,
Rodina Hanna,
Dong Hao Li,
Diana Carlson,
Lingjun Zhao,
Christina Chu,
Yi Shan,
Jamie Moline,
Hao Liu,
Nathan Montgomery,
Imad Jarami,
Brenton Svacha,
Hirsch Vakaria,
Yingche Chien,
Aaron Tran,
Miranda Makowski,
Clayton Elwell,
Leslie Ebo,
Jack Fenton,
Karishma Anandan,
Edmund Tong,
Sharyana Sarkar,
Siddharth Anil Kumar Burat,
Agustin Perez Chavez,
Rohit Banerjee,
Gauri Patil,
Razan Andigani,
Anjali Chiaravuni,
Cesar Eduardo Ramos Chakweri,
Natalie Chan,
Surya Pratap Singh,
Keith Cosma,
Gokul Prabhakar,
Trevor Underwood,
Marco Antonio Valdez Calderon,
Ryan Spencer,
Alavind Krishna Kumar,
Christopher Spencer,
Joseph Kennedy,
Everett Hume,
Manav Prapakar,
Emily Bentz,
Junkai Zhang,
Wood Monji,
Yushi Zhang,
Dr. Ava Mauser, engineered protein nanoparticles as therapeutics for gliomas.
Chi Dai,
Department of Biomedical Engineering 2024 inaugural class of AMPED students, Lauren Moudry,
Yanxi Lin,
Zoe Jones,
Anureka Ravikumar,
Lauren Terry,
Manohar Bhatt,
Jordan Blaine,
Rahul Swamapakula,
Brooke Behrens,
Jamul Premakumar,
Catherine Suarez,
Harikrishna Situramu,
Christopher Jeffers,
Jwalunda Giranak,
Tyler Tish,
Alisa Tambakis,
Luke Fisher,
Ayushi Srivastava,
Connor Anellis,
Dr. Peter Mitrano, data-efficient robotic manipulation of deformable one-dimensional objects with unreliable dynamics.
Mitchell Cook,
Billy Mazzotti,
Summer Motley,
Department of Nuclear Engineering and Radiological Sciences, Oh Juan Kwan,
Robin Pfeiffer,
Andrew Panter,
Juliana Canton,
Jr., James Baker Jr.,
George Rabati,
Iquan Caleb,
Eldon Shu,
Jamalina Jamaluddin,
Raj Patel,
Michael Johnson,
Isun Chang,
Dr. Jin Wang Tang, Online and Offline Learning Algorithms and Operations Management. Oh, is this IOE? Are you IOE?
Joel Pingle,
Dr. Jing Shu Fei, Optimization methods for mixed integer control problems and complex systems. Guess we're in IOE.
Department of Integrative Systems and Design, Nikki France.
Dr. Zhangju Shen on algorithmic advances for maximum entropy sampling.
Lucas Reddy, Red Chinchilla.
Continuing industrial operations engineering. Chloe Chi.
Ishwar Reddy Tama.
Baisheng Liu.
Vashuth Venishetty.
Tolulope Oladele.
Theodore Masterson.
Yijia Lan.
Daniel Massar.
Haochung Liu.
Danny Adamson.
Rufei Li.
Maya Hamka.
Yirang Zhang.
Reagan Mishra.
Yanru Guo.
Neil Tusay.
Changyua Zhang.
Adama Dianj.
Bing Xing Xiang.
William Stan.
Ashe Chokshi.
Danielle Bikas.
Ahmad Fadel Shamashani Saleh.
Elizabeth Lee.
Xiangping Xu.
Waivaf Kolchashita.
Haoran Zhao.
Tavun Raghavdian Kumamare Salvam.
Rachel Divinagracia.
Santosh Girahamarin Banjwaj.
Reem Rashid Yunus.
Samya Sharma.
Cynthia Joy.
Arihat Jane.
Yathrat Bhatt.
Kate Peterson.
Ansh Patel.
Taylor Rowe.
Menying Ling.
Ichechiwe Welly.
Sutong Chen.
Michael Strick.
Xiangling Shi.
Alex Schrock.
Ting Yu Lin.
Michelle Appledorn.
Su Shuang Shang.
Jamie Betker.
Kaishin Mao.
Briannon Shaker.
Tyler Smith.
Max Krusher.
Vincent Larson.
Bridget Beaton.
Justin Meyer.
Catherine Kolar.
Alexios Avasuglu.
Zachary Chambers.
Charles Bienert.
Ashraf Al-Oke.
Wong Yong Kang.
Ken Muniz.
Jared Pavlik.
Gabriel Moises Rodriguez Fernandez.
Aiden Fitzgerald.
Alexander Camilo.
Roxana Martinez Bernal.
Pauline Reisky.
Elizabeth Hoyt.
Claudia Zimmerman.
Isabel Rolfe.
Thanina McLoof.
Santiago Correa.
Mantavia Patel.
Nick Tran. Dr. Yifan Lee, Model-Based Work Assessment, combining spatial and temporal modeling for structured proactive work analysis.
Amogse Desai.
Catherine Kobitis.
Sylvester Kuo.
Zhen Hu.
Matthew Sang.
Yuzhou Liu.
Sophia Shi.
Muhammad Avaiz Sultan.
Paula Santana.
Mechanical engineering. Shujia Lang.
Adarsh Rajpal.
Zhuyao Zhou.
Harshad Honwad.
Hanyao Liu.
Soham Salholtran.
Yuchen Chen.
Arvin Varadaranjan.
Ziyang Huang.
Sumuk Manjunath.
Qilin He.
Ashwin Ramanan Yegapapan,
Jiqing Qin,
Aditya Natman,
Kumara Vishnu Ramesh,
Jacob Just,
Jessica Dillon,
Megan St. Pierre,
Dr. Krishikesh Danawe, role of phononic crystals in elastic wave focusing, guiding, and sensing applications.
Christopher Gorman,
Jackson O'Connell,
Tuhin Bagi,
Dr. Nishant Jalkawanaka, preemptive interventions for car sickness mitigation and their effects on passenger tasks.
Rowena N.,
Dr. Siddharth Rath, on the zeros of flexible systems.
James Sukumnuth,
Quan Le,
Matthew George,
Prahasha Gulam,
Sumit Tripathi,
Kazuki Osawa,
Department of Electrical and Computer Engineering, Amanda Liz,
Nicholas Pitt,
Michael Kane,
Dr. Eve Nazon II, estimation of knee joint impedance during walking and its implications for robotic control and beyond.
Menelik Witherspoon,
Shagun Praek,
Kanishka Panda,
Elizabeth Healy,
Ayan Majumdar,
Brianna Fogel,
Amanda Margolis,
Lanzhao Chung,
Sweta Subaya,
Neil Sinha,
Audrey Cook,
Erica Liu,
Fan Liu,
Salvador Chavaria,
Stanley Lin,
Reed Bacchus,
Chia Hong Lin,
Avaristo Garcia Reina,
Anisias Kusamajaya,
James Bryn,
Saeed Joseph Raful,
Maya Kaufman,
Varun Venkat Rao,
Cole Chaffin,
John Jiang Yi,
Karen Reyes,
Yang Zhang,
Natalie Paracha,
Anirudh Lakshmi Narasimhan,
Mohammed Burley,
Naurin Mohammed,
Ali Al-Khalifa,
Sachin Salim,
Mohammed Al-Shamlao,
Shubham Deshpande,
Shrey Kala,
Helena Thomas,
Arish Shah,
Samat Sethi,
Aditya Paranjapi,
Jivana Reddy,
Yuyan Chen,
Vedant Satav,
Yue Shang Run,
Xiaoji Wang,
Guangyi Liu,
Dion Zhao,
Hao Chi Pan,
Huiji Apan,
Jiangbo Yu,
Yifang Fu,
Yuxin Ma,
Abdulhadi bin Sifran,
Chunzhou Feng,
Akil Daniel Ivan,
Kewei Shou,
Ishan Shaitye,
Xingjian Xue,
Vaishnavi Bushmo,
Fernando Villavicencio,
Madhulika Lingamugundala,
Chia Chun Chung,
Ayushman Tripathi,
Xin Yu Wei,
Yashesh Raghu Gowda,
Rohan Raskar,
Pratik Joshi,
Sahash Jaisankar,
Avinash Gupta,
Sumit Badunsi,
Ankita Chandra,
Ajitesh Shukla,
Vibhor Gupta,
Karine Shetri,
Ayush Salanki,
Gaurav Jor,
Dak Shende,
Dash Devangabi Patel,
Shubham Shedgay,
Sidakip Chada,
Amina Shrestha,
Kush Janwate,
Chung Hao Lo,
Aditya Balakrishnan,
Bharathraj Muladhiraran,
Sizir Sanagala,
Leo Kim,
Siddharth Chaval,
Peter Katani,
Computer
Yushin-
Science and Engineering, Yinhua Yang.
Yushin Chi,
Shifan Zhu,
Tian Hao Wang,
Pranav Bhupala,
Hyun Yu Zhao,
Daniel Chechelnitsi,
Ayush Rajankar,
Vicente Bodavilla Riquelme,
Ning Liang,
Liang Yuan Wu,
Alexander Jaraki,
Katsumi Ibaraki,
Sikant Avrasu,
Nam Ho Ko,
Anmol Mansingh,
Chen Huang,
Dr.
Yijie-
Zhongyu Li, solving Poisson inverse problems in phase, retroval, and suspect imaging.
Yijie Shi,
Jiang Zhang,
Ari Singer,
Siddharth Rao Apala,
Reynardus Joseph,
Zach Khan,
Jifeng Wang,
Brian Sang,
Elizabeth Lippin,
Dr. Qian Wei Sang, narrowband obligation circuits and systems for long-range application like insect tracking.
Jim Mao,
Tian Jiang,
Sang Hyung Shim,
Evan Urban,
Ankit Udupa,
Isidro Garcia,
Hader Baloch,
Tate Fisher,
Ranyan Dai,
Lian Chen Tian,
Yushi Shang,
Carl Garish,
Akash Bharat,
Wenjin Ding,
Aditya Vasudevan,
Aditya Rao,
Anuj Tambwekar,
Spencer Bukwikio,
Creighton Glasscock,
Tharum Madali,
Jacob Sansom,
Misael Ortiz,
Maya Rao,
Austin Wexler,
Meredith Benson,
Changlong Wu,
Riya Agarwal,
Jingchen Ma,
Mihail Shashko,
Huyen Yang,
Benjamin Miller,
Hong Zon,
Zachary DeRoja,
Jianping Shen,
Lindsay Forget,
Guang Zezhu,
Pinglung Lai,
Xin Chao Za,
Yanni Chan,
Tomas Fernandez,
Hang Jiang,
Yifan Wang,
Lingzhen Sun,
Jianming Ya,
Norman Wen,
Joseph Broshevich,
Peter Lee,
Jerry Shu,
Jixiang Zhou,
Yufan Huang,
Xiang Yu Xin,
Xinling Lu,
Benjamin Zhang,
Daniel Yu,
Andrew Shuang, Jaewoo Kim,
Xian Yang Fan,
Ayush Singh,
Jackson Muller,
Alexander Morton,
Cody Dempster,
Zekin Wong. Matthew Ruiz.
Alan Tondrick.
Daniel Gorlick.
Guthrie Tabios.
Alexandro Beloy.
Riley Bridges.
Richard Wong.
Christian Foreman.
Harvin Mummick.
Andrew Sheffer.
Anisha Agarwal. Farzad Siraj.
Ashwin Saxena.
Raisha Deng.
Kohi Nishiyama.
Shosheng Sun.
Daniel Lee.
Zige Shang.
Ziyu Liu.
Xing Tong.
Longju Bai.
Yiwei Peng.
Xinyun Li.
Suyang Zhang.
Zhangnan Lu.
Anisha D'Souza.
Jian Chen Wang.
Sai Deepti.
Xianqian Quang.
Akshat Porwal.
Kifan Zhang.
Pratamesh Joshi.
Sarav Telge.
Zachary Goldston.
Keegan Pinto.
Zachary Eichenberger.
Hayden Walker.
Daphne Tsai.
Durkish Mugundan.
Xixiang Zhu.
Dr. Christine Wenson, Design Techniques for Scalable, Fully Integrated CMOS Digital Beamforming Receivers.
Royi Zhan.
Daehoon Siang.
Anuraj Bangera.
Sunghoon Lee.
John Hong Chen.
Hong Jiao Chiang.
Seth Sandoval.
Yicheng Liu.
Chirag Bangera.
Rashitha Golamudi.
Dr. Shezhang Liu, Exploiting Structure in Safety Control.
Dash Munaswari.
Gongwei Chen.
Xiang Yu Zhao.
Ling Xiao Mo.
He Shui.
Thomas Westrick.
Xin Yun Lu.
Nikita MV.
Wenqing Li.
Xiao Chao Peng.
Thaddeus Kohler.
Shen Xuan Xu.
Ayu Tang.
Yongxing Huan.
Do Young Kim.
Min Suang Tung.
Hao Ron Lee.
Jisoo Kim.
And finally, Bowen Lee.
My goodness. Well, let's hear it one more time for the class of 2024. And let's thank our name announcers and all the folks who worked behind the scenes to make this such a great event. Let's thank them, please. Now to finish us off, we will sing the University Alma Mater, the Yellow and Blue. After we sing the Alma Mater, please remain in your seats until the platform party has left the stage. Then, please make use of all the available exits when leaving Chrysler Center. Anyone using a wheelchair or with other special mobility needs, please proceed to the northeast or southwest exits. Please follow the directions of the event team members stationed around the arena to find the nearest exit. Now, as you are able, please stand for the singing of U of M's alma mater. You will find the words on the scoreboard.
forget where I'm from. Cause looking in your eyes, like looking at the sun. I feel like you're the moon, I feel like I'm the one. I wanna get numb, 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 numb. I wanna get numb and forget where I'm from. Cause looking in your eyes, like looking at the sun. I feel like you're the moon, I feel like I'm the one. I wanna get numb, 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 numb. Wanna get numb, go crazy, wanna wild out. Cause lady, life's so short but amazing. Late night party in the basement, hotel lobby and I'm wasted. Just reached into my savings, I'll do it too if you take it. Yeah, life's only what you make it. I wanna get numb and forget where I'm from. Cause looking in your eyes, like looking at the sun. I feel like you're the moon, I feel like I'm the one. I wanna get numb, 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 numb. I just wanna get lost tonight and dance with you. I just wanna get way too high, let's set the mood. You're my fantasy, yeah. I don't wanna fall asleep, yeah. There's nothing in this world I'd rather do. I wanna get numb and forget where I'm from. Cause looking at your eyes, like looking at the sun. I feel like you're the moon, I feel like